Good morning. In this session, we evaluate the preparation and chemical tests for chlorine. Chlorine occurs naturally as salts within the Earth's surface. In order to obtain chlorine from naturally occurring substances, we use rock salt, which is introduced in the down cell for electrolysis. That process yields exclusively pure chlorine gas. We can also obtain chlorine using brine solution and the mercury cathode cell. In both cases, since the chlorine obtained is pure, we can assume that we can fabricate chlorine on a large scale using the industrial processes of the down cell electrolysis or the mercury cathode cell. However, at the laboratory, the conditions are fairly different. In this case, to be able to prepare chlorine at the laboratory, we need mainly oxidizing agents, namely manganese 4 oxide or potassium manganese 7, and the carrying agent for the chlorine will be concentrated HCl or concentrated hydrochloric acid. In the first case, when you want to prepare chlorine gas from manganese 4 oxide, we take conch hydrochloric acid, we treat it with manganese 4 oxide and heat intensely because the reaction happens to be slow. In that process, chlorine is precipitated alongside manganese chloride and water. The water serves the purpose of absorbing the excess unreacted HCl gas, since the hydrochloric acid is normally volatile. Now, this gas is collected by the method of downward delivery of gas simply because it is denser than air. And then we proceed to test to confirm it by using litmus paper. Now, when you take moistened litmus paper, red and blue, and pass chlorine gas through it, the blue litmus paper will turn red while the red will remain red. Then, after a while, both will turn white, showing that chlorine has a bleaching property. In this case, it removes and cleans off the color on the litmus paper. Therefore, the common test for chlorine gas is litmus paper, which is moistened, and the chlorine gas bleaches both blue and red litmus paper. Initially, it turns the blue litmus paper red and then bleaches it, making it white. Number 2, in the event that you want to prepare chlorine gas from potassium manganese 7, then you will still take the concentrated hydrochloric acid. Now, the conch hydrochloric acid is added onto the potassium manganese 7, where it precipitates chlorine gas, potassium chloride, and manganese chloride alongside water. The reaction is fairly fast and no heating is required. Where then do you obtain the hydrochloric acid? Hydrochloric acid, as initially stated, is prepared by the thermosynthesis of hydrogen and chlorine, and in that process, the ratio of hydrogen to chlorine is 1:2, simply because hydrogen burns explosively. And once the hydrogen chloride gas is formed, it is dissolved in water through the slaking process of trickling down water onto it, forming aqueous hydrochloric acid. Now, at the laboratory, we could prepare the required hydrochloric acid in the following way. To begin with, we need a metal chloride, the carrier of the anion form of the acid. Now, when we take a metal chloride such as sodium chloride, we take a conch acid such as nitric acid and synthesize the two. The precipitation will be of sodium chloride and conch hydrochloric acid. Secondly, in the event that you took magnesium chloride and the dibasic sulfuric acid in the conch state, it will precipitate magnesium sulfate and readily form conch hydrochloric acid. In this case, we agree that this will be gaseous in the initial steps and only becomes acidic when dissolved in water. Therefore, we can say that hydrogen chloride gas is prepared at the laboratory by using metal chlorides and conch acids of respective valencies. In that case, we have prepared HCl, and then the HCl is said to have a varied range of applications. Namely, HCl, when dissolved in water, forms hydrochloric acid. HCl can be used as a test agent for ammonia, where when it is gaseous, HCl forms white films with ammonia, and when it is aqueous, it forms a colorless solution. The same way, HCl can be used as a fumigant, and it is a main cleanser of swimming pools. In this case, it has its own importance. And therefore, we have evaluated briefly what we are saying is the preparation of chlorine, the preparation of hydrogen chloride gas, the preparation of HCl solution, and we have said that to prepare chlorine gas, you need oxidizing agents and conc hydrochloric acid. Number 2, we have looked at the chemical tests for chlorine, and we have said that to test for chlorine gas, we need moist litmus paper, where it turns the blue litmus paper red and then bleaches it. What about chloride ions? Well, chloride ions, as mentioned, are derivatives of chloride-carrying salts. Now, the chloride is the ion form of chlorine. So, when we do the chemical test for chlorides, this follows. The chemical test for chloride ions shows that 1, we have agents. The agent 1 will be silver nitrate, and the agent 2 will be lead nitrate. In the first case, when we want to test for chloride ions, simply because it is an anion and normally exists in compound form, we have to eliminate the cations. Therefore, the first step is to treat the sample solution that is required to be tested for chloride ions with dilute nitric acid. Now, the dilute nitric acid will precipitate normally nitrates, which are aqueous solution, thereby releasing the chloride ions into solution and readying them for the required test. In this case, therefore, once we have treated the sample test solution with dilute nitric acid, we proceed to add either silver nitrate or lead nitrate. What happens when we add lead nitrate is that the presence of chloride ions leads to the precipitation of lead chloride, which is a white precipitate. Therefore, we can say that the test for chloride with silver nitrate produces a white precipitate. This white precipitate is found to be insoluble in excess dilute nitric acid. Number 2, in the event that you use lead nitrate to test for the chloride ions, the same procedure will follow of first treating the solution with dilute nitric acid to eliminate the cations. Now, once chlorides are freed, we add the lead nitrate, and we expect that the presence of chloride ions interacting with lead nitrate would precipitate lead chloride. In this case, we again form a white PPT. This white precipitate is not readily soluble in excess dilute nitric acid, nor in any other excess dilute hydrochloric acid or acid as mentioned. However, with gradual heating, we find that the solution will dissolve in excess dilute hydrochloric acid or excess dilute nitric acid. Therefore, we can say that when you test chlorides using silver nitrate, you do not require to heat. It will form a white precipitate, and the white precipitate will not be soluble in excess acid. When you use, however, lead nitrate to test for chloride, it will form a white precipitate which is insoluble when unheated, but soluble in excess dilute acid when heated. Thank you. As we have said, therefore, chlorine has its own importances. As we initially said, chlorine is a bleaching agent. Chlorine is a fumigant. Chlorine can be used as an antiseptic agent. It is a purifier of water and can be used in purifying drinking water, and in the form of HCl, it can be used to cleanse swimming pool. Thank you very much.